Okay, so in last class we have done the Nernst equation. So if you remember, the Nernst equation was, Advika, can you hear me now? Adarsh, am I audible to you, right?
Yes, ma'am. I can hear you.
Yeah, I think she. Okay. What was Nernst equation which we have discussed? E is equal to E naught minus 0.0591 by N log concentration of products by concentration of reactants. That is the equation which we have done last time. Adhika, I'm not still not audible to you.
I can hear now.
Okay, okay. So this is the Nernst equation which we have discussed this last time, right? Tell me. We have done Nernst equation last class.
Yeah, yes, ma'am.
So this we have discussed where E naught cell is the standard electrode potential, which is E naught of cathode minus E naught of anode. And P and R is the concentration of reactants and products. So now we have done that. We have to do the next topic, which is relation between equilibrium constant and E cell. What is the relation between equilibrium constant and E cell? So what is the relation when the reaction is at equilibrium? The value of E cell becomes 0. When the reaction is at equilibrium, E cell value becomes 0. And you know that concentration of products by concentration of reactants, it is called equilibrium constant Kc. When the reaction is at equilibrium, E cell is 0 and concentration of products by reactants is called equilibrium constant Kc. So it becomes 0 is equal to, if you substitute in Nernst equation, what it becomes? E naught cell is equal to 0 minus 0.0591 by N. I think we have done this one, no? Naught cell comes out to be 0.0591 by N log Kc. So that is the relation between electrode potential and the equilibrium constant. So where E naught cell is a standard standard cell potential and N is the number of electrons exchanged, Kc is the equilibrium constant. So that is the relation between Kc and E naught cell. And the last thing, we will just finish the formulas, then I will explain the numericals. Last is Gibbs free energy change. Is delta G. What is Gibbs free energy change? It is the amount of useful work that can be obtained from the cell. amount of useful work obtained from a cell. Last year you have studied in thermodynamics about delta G. Advika, can you tell me what is the sign for delta G if a reaction is spontaneous?
Negative.
Negative. If delta G is less than 0, then it is spontaneous reaction. If delta G is greater than 0, then the reaction is non-spontaneous. Others, if delta G is equal to 0, then
Equilibrium.
reaction is at equilibrium. And there are two relations, no derivation in your syllabus. Delta G is equal to minus NF E cell. N is again the number of electrons exchanged, and F value is 96,500 coulombs, which is a Faraday's constant. And if it is standard Gibbs free energy change, same formula, just instead of E cell, it becomes E naught cell. N is number.
Ma'am,
Yes,
Are
Pawan.
we just revising upon the previous topics?
This we have done na last class.
Yeah.
I was thinking we have that this is the last thing. Now I'm starting the new topic after. We have practiced a numerical also based on Gibbs free energy change.
Yeah, ma'am.
Okay. So that is the Gibbs free energy change. Okay, minus NF E cell or delta G naught is equal to minus NF E naught cell. So that is all we have done last time. Now I'm starting the new topic, which is entirely different. That is conductance, and quite easy. This is the next topic, conductance. Now, in conductance, first thing that you should know what is Ohm's law. Pawan, you know what is Ohm's law?
I
In physics,
have an idea.
tell me.
Is it the volts is equal to current into resistance?
The current flowing through a conductor is directly proportional to the potential
Voltage.
difference
Yeah,
applied across
potential.
the electrode. So this you know V is equal to IR. V is the potential difference, I is the current, R is the resistance. So R is resistance, which is the restriction to the flow of current. It is called restriction to the flow of current. More the resistance, lesser the current flows. Units for R is ohms. Now, second thing, on what factors R depends? Others, you know, are the value of resistance depends on which factor? R is directly proportional to any idea? Length of the conductor and inversely proportional to area of cross section.
Area, yeah.
Just 1 minute. R is directly proportional to length and inversely proportional to area of cross section. And if we remove the proportionality sign, we add one constant, which is rho. R is equal to rho L by A. What is rho here? Rho is resistivity, or it is also called specific resistance. And what is L by A called? L by A is G star, which is called cell constant. L by A is G star, which is cell constant, or rho is resistivity. R is equal to rho L by A. Advika, can you tell me what should be the units for rho?
It's ohm meter.
Yeah, units of rho is ohm meter. Because if you calculate rho becomes equal to R A by L. it becomes ohm, meter square by meter, ohm meter. So units of rho is ohm meter or ohm centimeter. Now third is, after this there is a conductance. Conductance is denoted by G. It is the reciprocal of resistance. Conductance is the reciprocal of resistance. So its units will be ohm inverse, or it is known as Siemens S. Siemens, it is written as capital S. That is conductance, which is the reciprocal of resistance. Now next thing is conductivity. Conductivity is denoted by kappa. Or K, you can say K also. Conductivity is kappa. How will you define its definition is very, very important. It is the conductance of 1 centimeter cube of a solution. It is the conductance of 1 centimeter cube of a solution. And kappa conductivity is the reciprocal of resistivity. So its unit becomes ohm meter is a units for rho, so it becomes ohm inverse, meter inverse, or we can also yes,
Now, what's the unit for conductance?
conductance is ohm inverse or Siemens.
Okay.
So conductivity is conductance of 1 centimeter cube of solution, which is equal to 1 by resistivity, or its units will be ohm inverse, meter inverse, or Siemens meter inverse. These units are very, very important because sometimes they ask you in MCQ or in match the following thing with the units. On this thing, then I will tell you the next term, which is molar conductivity. Now next is molar conductivity. As the name suggests, molar conductivity. Pavan, can you tell me what should be the molar conductivity?
Uh,
What should be the difference between conductivity and molar conductivity?
I don't know. Ma'am.
Molar means we have specified the
Mass.
1 mole. Okay, when you dissolve 1 mole of electrolyte in solution, whatever ions produced, their
Conductivity by its smaller concentration.
by 1 molar. So it is the conductivity of 1 molar of the solution. Molar conductivity is the conducting power of all the ions produced by dissolving 1 mole of electrolyte in solution. Is the conducting power of all the ions produced by dissolving 1 mole of electrolyte in solution. It is denoted by lambda m. Total conductivity is kappa. Now tell me one thing. Let us suppose you have 10 molar solution. Its conducting power is, or you can say its conductivity is 100. Now others, you tell me what should be the conductivity for 1 molar solution?
Conductivity.
1 molar solution ka is 100. 1 molar it should be. It's simple mathematics.
10.
10. That is 100 by 10, which is 10. So
Yeah.
the total conductivity is kappa. When you are calculating for 1 mole, we will divide the kappa with the total concentration. Kappa by C. Kappa is total conductivity. When you divide the conductivity with the concentration, it will give you the conductivity of 1 molar solution. And this thing is multiplied with 1000 factor. Why it is multiplied with 1000 factor? Because kappa value is in Siemens centimeter inverse and concentration is in mole per liter. So when you have to convert liter to centimeter cube, there is a 1000 factor. So this 1000 is the conversion factor from liter to centimeter cube. And its unit is Siemens centimeter square per mole. So I will repeat, to convert liter to centimeter cube, this 1000 factor is there. So that's both conductivity and concentration should be in centimeters. So lambda m is equal to kappa by C into 1000. Okay, now we will, these all are the definition. We will do small derivation. Okay, you tell me what is the formula for resistance?
Rho L by
L by A. If you take rho on this side, 1 by rho into R is equal to L by. What is 1 by rho?
conductivity.
Conductivity. And what is L by A? L by is called L constant. L by is cell constant. So there is one relation, conductivity into resistance is called cell constant. In this is same thing, R is equal to rho L by A, because in numericals mainly we do the relation between conductivity and resistance. So that is a relation, conductivity into resistance is called cell constant, which is L by A. And write down the value of cell constant. Value of cell constant same for a particular cell. The value of constant is same for a particular cell. I will tell you what does this line means. From the numerical, I will explain. Now we will practice few numericals based on these formulas. Then I will come to the next topic.
Ma'am, can you scroll a little bit up? Is there anything before this?
Just
Oh yeah, okay.
all of you write down the first question. Is it done? The writing part, or shall I wait?
Just 1 second, ma'am.
Okay. cell filled with 0.1 molar KCl 100 ohms. If the resistance of the same cell when filled with 0.02 molar solution of 520 ohms, calculate conductivity and molar conductivity. 0.0 molar KCl solution. And it is given that
Ma'am, your voice is not clear.
now it's fine.
Yeah.
Conductivity of 0.1 molar KCl is 129 Simon per meter. So this is a question. Write it down, then I will explain one question. Resistance of a conductivity cell filled with this solution is 100 ohms. And if the same cell is filled with 0.02 molar KCl, its resistance is 520. Calculate conductivity and lambda m of 0.02 molar and conductivity of 0.1 molar KCl is given. Okay, I will explain this numerically. In this case, they are talking about two solutions, 0.1 molar solution. There are 2-3 small points here. Just listen carefully. There is a two solutions, 0.1 molar and 0.02 molar. First, we make two columns. Okay, there are two solutions given, 0.1 molar and 0.02. For 0.1 molar solution, resistance is given, which is 100 ohms. Conductivity is given, which is 1.29 Simon per meter. You have to find the conductivity and molar conductivity of 0.2. Resistance of 0.02 is 520 ohms. Kappa and lambda m we have to find. This is the data given. And one more thing is given in the question, same cell. So when the word same cell is there in the question, it means the cell constant value is same for both the solutions. So what you can do, from this solution we can find cell constant and then we can substitute the cell constant value in the second solution. See, this formula just now we have derived, kappa into R is G star. This kappa value 1.29, resistance is 100 and it becomes equal to G star. So it becomes 129 per meter G star. So cell constant value is 129 per meter. But it's always better to represent the value in centimeters, because in lambda m we are calculating the value of lambda m in terms of centimeter. So it's better to convert it here only. 1 meter is 100 centimeter. 1 meter inverse is 1 by 100 centimeter inverse. So it becomes equal to 1.29 centimeter inverse the G star value. We can use the same value in the next part. So G star is 1.29. You can find kappa, same formula, kappa into R is G star. So kappa is equal to G star by R. Star is 1.29. Kappa is 520. So it comes out to be 0.0248, I think. Yeah. You can say 2.48 into 10 raised to power minus 2. 0.248 into 10 raised to power minus 2. That is the kappa. Simon per centimeter. Then similarly, you can find lambda m, which is kappa by C into 1000. Kappa is 0.248 into 10 raised to power minus 2 by 0.02 concentration into 1000. So when you solve it, you will get 124 Simon centimeter square per mole. So that is the answer. All of you just check once, read the questions, see the solution and tell me if you have a doubt. I will repeat. So this formula kappa into R is equal to G star we are using in this numerical.
Ma'am, I didn't understand the first part of the solution.
0.1 molar.
Yeah.
See, what is given in the question for 0.1 molar KCl? Resistance is given 100 ohms. And in last line, kappa of 0.1 molar KCl is 1.29 Siemens per meter. These two things were given. So it is given that if the resistance of the same cell when filled with 0.02, it means for both the solutions, one thing is common. What is that? Cell constant value is common for both the solutions because they are using the same cell. So what we have done from the first solution, we calculated cell constant value. Kappa into R is equal to G star. It comes out to be 129 per meter. Because lambda m we need answer in centimeter. So that's why we have converted at this step itself meter to centimeter.
Ma'am, so like I had a doubt about the unit because like R into kappa, like it's ohm, Siemens, meter, and volts, right?
Which units of this thing? Kappa into
Yeah.
R. What is the unit for kappa?
Siemens meter.
Siemens is ohm inverse and meter inverse, right? And what is resistance unit? Ohm. So when you multiply kappa into R, ohm inverse and ohm gets cancelled.
Yeah. Okay.
So it becomes meter inverse.
Okay.
Because Simon and ohm inverse is same thing.
Yeah.
Others, Pawan, is it clear this numerical? Any doubt here?
No doubts, ma'am.
No doubt.
Okay, now I am giving you one numerical. All of you solve it and tell me the answer. It's almost same type of numerical. Write down. All of you are done with the writing part?
Ma'am.
Now
Yes,
write
ma'am.
down question. When a cell is filled with 0.1 molar KCl solution. When a cell is filled with 0.1 molar KCl solution, it has resistance 85 ohms at 25 degrees Celsius. At 25 degrees Celsius. The same cell was filled with an aqueous solution of aqueous solution of 0.052 molar. Cl. The resistance becomes 96 ohms. Just I will write in short. Resistance becomes 96 ohms. Calculate same question. Calculate conductivity and molar conductivity of 0.052 molar solution. It is given that conductivity of 0.1 molar KCl is 1.29 to 10 raised to power minus 2 Simon per centimeter. Now do this one.
One second, ma'am. I'll be back.
Okay. Okay, Pawan, you tell me what should be the first step in this numerical?
First one, it's to find G.
G or G star?
G star.
Okay, tell me what is given. For 0.1 molar solution, what all things are given?
We know the conductivity of it,
Mhm.
and we know its resistance,
What is resistance for this?
85 ohms.
And what is conductivity for this?
1.29 into 10 to the power minus 2.
Now, how to find G star? Why we are, first tell me
Wait,
why we are finding G star for this?
because with this, we'll have to find K.
Of second solution, because G star is common for both the solutions. Cell constant value is common. So what is our relation between kappa and G star? Which formula we
Uh,
have to use?
G equals R into K.
Don't say G. G is conductance.
Okay,
It's
okay,
G
yeah.
star.
G star, G star, G star.
Kappa into R is G star. So what is kappa? 1.29 into 10 raised to power minus 2. R is 85. And you can find G star.
G star comes for me as 110.5 into 10 to the power minus 2.
It becomes 1.10, right?
No,
29.
yeah, 1.10. 1.105.
1.09 is coming.
I
Round it off something.
yeah, 1.29, I took it as 1.3.
But it's coming 1.0965. So exact value is this one. So 1.09 you can take. Centimeter inverse. Advika, what should be the next step?
We have to find conductivity.
So how we can find that?
We found G star and the resistance is 96 ohm. So conductivity is G star by R.
1.0965 divided by, what is the resistance given? 96, na?
Yeah.
I think it's coming out to be 0.121. Lambda, you use the same formula. 0.121 kappa by C. C is 0.052. 2000. Now tell me the answer. What is the answer for this? It's coming 0.011. 0.011. You are back?
Yes, ma'am.
So that was exactly same numericals, only the values were different. Now I'm giving you the another one. All of you write it. The conductivity of, I'm sharing the board again. The conductivity of 0.2 molar KCl. The conductivity of 0.2 molar KCl at 298 Kelvin. 2 molar KCl at 298 Kelvin is 0.0248 Simon per centimeter. Calculate molar conductivity. Calculate molar conductivity. All of you do it. I will repeat, the conductivity of 0.2 molar KCl is 0.0248 Simon per centimeter. Calculate molar conductivity. Just tell me how to solve this one.
Ma'am, I couldn't hear you. Who did you say?
No, I'm asking to others. You have to tell me how to solve it.
Okay. Um, Okay, so isn't it just using that formula though?
Which formula?
The kappa into 1000 by molarity,
What is kappa value?
0.0248.
What is C value? Molarity?
0.2.
Yes. So the answer will be, when you solve it, 124. What are the units for molar conductivity?
S into centimeter square and mole inverse.
So like this you have to solve. I'm giving you one more numerical, then we will come to the next topic. Write down the next one. The resistance of a conductivity cell. The resistance of a conductivity cell of 0.001 molar KCl is 1500 ohms. Calculate cell constant. If conductivity of same solution (0.146 into 10 raised to power minus 3 Simon per centimeter). Now solve it and tell me the answer fast.
Ma'am, can you just excuse me for 1 minute? I'll be back.
Okay. Yeah, Advika, you tell me how to solve this one.
Ma'am, silicon equal to R into conductivity.
G star is equal to R into conductivity. Yes, tell me the values.
R is 1500 into 0.146 into 10 raised to minus 3.
Yes. So answer comes out to be 0.219. What should be the unit?
Centimeter per centimeter.
Per centimeter. So that was a simple question. Now we will come to the next topic. So this is all about the important terms and few formulas. And one more thing here, how to calculate resistance practically. I think this also you have done in physics, Wheatstone bridge. Calculate resistance experimentally. Others, you have heard about Wheatstone bridge to calculate the resistance of the solution.
What?
You heard about that term, Wheatstone bridge?
No.
No. Advika, you know about that?
Yeah.
So how we can calculate resistance experimentally? There is one thing which is known as Wheatstone bridge. This mainly they want to ask question from that. That is just for your knowledge. We'll discuss briefly. What is Wheatstone bridge? In this, you have four resistance connected in series like this. This is resistance 1. This is resistance 2. This is resistance 3. And this is resistance 4. R1, R2, R3, R4. And R1 is a variable resistance which we can change with the rheostat. And R2 is the unknown resistance. R3 and R4 are the fixed resistance, and they are connected with a key and a battery. And these points are connected with a galvanometer to check the current. Now, what is R3 and R4 are the fixed resistance. R1 is variable, R2 is unknown, which we find. And they are connected with the battery key, and in center they are connected with a galvanometer which measures the current. So you have to adjust the resistance R1 in such a way that galvanometer shows null point. Null point means it will show the zero reading. I will repeat, you have to adjust the resistance R1 in such a way that the galvanometer shows the null point. Null point means there should be no deflection in the galvanometer. So at null point is the rule that R1 by R2 becomes equal to R3 by R4. Now R3, R4 are the fixed resistance. We know the value. R1, the value at which the galvanometer is showing null point. So that is the value of R1. And similarly, you can find the value of R2. It becomes R1, R4 by R3. So that is the way to calculate the resistance of the compound. So that is R3, you can write here, R3 and R4 are the fixed resistance which we cannot change. R1 is the variable, and we have to adjust the variable resistance in such a way galvanometer shows no deflection. No deflection means null point. So at null point, R1 by R2 becomes equal to R3 by R4, and R2 we can calculate R1, R4 by R3. There is one important question here. Okay, if we are using electrolytic solution, for electrolytic solution means the solution which can be converted into ions. For electrolytic solution, DC means direct current cannot be used. This is very important question. Direct current cannot be used. What is the reason why we cannot use the direct current for the electrolytic solution? The reason is, if we use the direct current, then it undergoes the electrolysis of the solution. The solution undergoes electrolysis, and the concentration of ions around the electrodes will change. And what happens due to that, the resistance should also change. So we will not get the exact value of resistance, because reason is because it causes electrolysis of the solution. Electrolysis means breakdown. Electrolysis of the solution, which changes the concentration, of the electrolyte near the electrode. Light near electrode, and then ultimately it will change the resistance. So instead of DC, we are using AC current. Alternate current is used. So if we use DC, it undergoes the electrolysis, means breakdown of the solution. New ions will be formed which gets concentrated near the electrode. So that's why the concentration near electrode will change, and ultimately the resistance will change. So instead of DC, AC current has to be used in the electrolytic solutions. Alternate current. So that is one reasoning question in this topic. Okay, now I'm starting the next topic, which is very important. Variation of conductivity and molar conductivity with dilution. Pavan, you are here?
Yeah, ma'am, I'm here.
Variation of conductivity and molar conductivity with dilution. This is very, very important reasoning topic and very easy also. Now, just now we have discussed what is conductivity. Others, you tell me, what is conductivity? What was the definition of that?
Conductance of 1 centimeter cube of a solution.
Yes, it is the conductance of 1 centimeter cube of a solution. Now, let us suppose I have this solution. Listen carefully this point. I have this much of solution and this is 1 centimeter cube. And in 1 centimeter cube, let us suppose I have 4 ions. The conductance is due to the number of ions. More the number of ions, more will be the conductivity. So let us suppose you have 4 ions in 1 centimeter cube of the solution, and that is the conductivity. So when I dilute the solution, I will add water to this. Now I have diluted the solution. On adding water, these number of ions will get distributed in more volume. Initially in this volume, you have 4 ions. But when you add water to that, these ions gets distributed in more volume. So number of ions in this particular area, it will increase or decrease? One of you can tell me? When we add, it will decrease because initially you have 4 ions. When you add water to it, these ions gets distributed in more volume. So number of ions per unit volume will decrease. And if number of ions are less, then the conductivity is also less. So how it varies with dilution? First you write conductivity. I will tell you how to frame the answer. First you write the definition. Conductivity is the conductance of 1 centimeter cube of solution. And you write on dilution, number of ions per centimeter cube decreases. So conductivity also decreases. Conductivity is the conductance of 1 centimeter cube of solution. On dilution, number of ions per centimeter cube decreases. So conductivity also decreases. Because these ions get distributed in more volume. Write down this, then I will explain how molar conductivity varies. Whether you can write dilution or you can write decrease in concentration, it is same thing. Now, how molar conductivity varies with dilution? One, what is the formula for molar conductivity?
Okay, it's K into 1000 divided by molarity.
Kappa by C into 1000. Here, the 1000 is just a conversion factor. We are not doing numericals now. So, I will just tell you it is kappa by C because 1000 is conversion factor. C is moles per liter. We can also write C as N by V, number of moles by volume. Because molarity is number of moles by volume of solution. And if we consider number of moles as 1, its molar conductivity, we can consider number of moles as 1. So we can also say lambda m is equal to kappa into V. When you dilute the solution, kappa value decreases. Just now we have discussed that conductivity decreases on dilution. And on dilution, volume will increase. It is found that increase in volume is much more than that of decrease in conductivity. Let us suppose volume is increasing 100 times, conductivity decreased only 10 times. Advika, you tell me then what should be the net change in the lambda m? It should increase or decrease?
Increase.
Increase. So we can say that lambda m increases with dilution. There is a decrease in conductivity and increase in volume. But volume increase is much more than as compared to decrease in conductivity. So lambda m value increases on dilution. You can write on dilution or on decreasing concentration, conductivity decreases and volume increases. But increase in volume is much more as compared to decrease in conductivity. So lambda m increases. So conductivity decreases on dilution and molar conductivity increases on dilution. Why is it so? These are the two reasons. Conductivity depends on number of ions which are decreasing per unit volume. Molar conductivity is product of kappa and V. So V is increasing much more times as compared to decrease in conductivity. So lambda m increases. Write down this, then I will explain how it varies for strong and weak electrolytes.
Ma'am, so here we don't multiply K with 1000, right?
Yeah, because here we are not doing any calculation, that is just a conversion factor. So we are calculating the relation between kappa and V. But when you are doing the numericals, 1000 factor should be there.
Okay.
Then now we will do variation of molar conductivity for strong and weak electrolytes. Variation of molar conductivity for strong and weak electrolytes. Now first thing, what is strong electrolyte and what is weak electrolyte? Pavan, tell me
Ma'am,
difference between strong and weak electrolyte.
1 second.
Like you know that strong acids, strong bases, what are those?
Uh, don't know. Are they the ones that are
Why HCl is a strong acid?
because it shows ionization?
Hmm. It's complete ionization or partial?
Uh, complete as such.
That is the strong electrolyte which are completely ionized in the solution. Strong electrolytes are those which ionizes completely in the solution. Ionizes completely in solution. For example, all strong acids and bases, NaCl, KCl, these all are strong electrolytes. So how it varies with dilution? See, lambda m increases for both strong and weak. But in case of strong electrolyte, it increases to a lesser extent. So write down lambda m decreases slowly on dilution for weak electrolytes. For weak electrolytes. Oh, sorry, for strong electrolytes. Now, why is it so? There is one relation for that. Lambda m is equal to lambda. I will explain all the terms here. Lambda m naught minus a root c. What is lambda m naught here? Lambda m naught is molar conductivity at infinite dilution. Molar conductivity at infinite dilution. Or it is also called limiting molar conductivity. I will explain the definition of that. Limiting molar conductivity. A is constant. Value depends on type of electrolyte. Type of electrolyte. This also I will explain what do you mean by type of electrolyte. And C is the concentration. This equation is known as Debye-Huckel-Onsager equation. This gives you the relationship between the lambda m molar conductivity and the concentration for strong electrolytes. Lambda m is equal to lambda m naught minus a root c. And lambda m increases slowly for a strong electrolytes on dilution. Write down this thing, then I will explain with the help of graph this topic. So what is this graph says? This graph is lambda m and root c for strong electrolytes. This graph you have to study right to left because we are studying dilution. Dilution means decrease in concentration. So we are studying from right to left. You will get like this. It increases with dilution, but it increases to a lesser extent. It's not a strong, great increase. It's just a small increase on dilution. The point where it cuts the y-axis, that is lambda m naught. Does it mean when you are adding water to the solution, the lambda m value keeps on increasing? A point will come Okay, after that, if you further add water, there will be no change in the lambda naught value. That becomes constant after this. And that is the maximum value of molar conductivity. That is lambda m naught at infinite dilution. Okay, when you add excess of water and after that, if you further add water, there will be no change in lambda m naught. Lambda m, that is known as lambda m naught. It is a maximum value of molar conductivity for strong electrolytes. What is A? A is constant. Its value depends on type of electrolyte. Type of electrolyte means, let us suppose I am writing KCl. Others, what is the charge on K and Cl?
Cl minus and
Potassium
K is
has
plus
plus.
positive.
So yes. So plus 1 minus 1. So we can say it is 1 electrolyte. NaF, sodium plus 1, fluorine minus 1 electrolyte. The charges. So these two have same value of A. The charges are same on cation and anion, their values are same. Let us suppose you have MgCl2. Advika, MgCl2, what is the charge on cation and anion?
Charge on anion is -1 and on cation is 2.
So it is 2-1 electrolyte. Pavan, in CaF2, what is the charge on calcium and fluorine? Calcium charges,
2,
fluorine charges.
1.
So that is same value of A. So for same charges, the value of A is same. These are the same type of electrolytes. That is the meaning of type of electrolyte. So if charges on cation and anion is same, then the value of is same. Now the question comes theoretically, why the value of strong electrolyte increases on dilution. You know that strong electrolytes are those which are completely ionized in the solution. If you have KCl, it is completely ionized. So why on increasing dilution, the conductivity increases? In this case, no more ions will be formed because they are already dissociated. Let us suppose in this volume, you have KCl, you have K plus ions and Cl minus ions. They are already dissociated. So when you dilute it, no more ions will be formed. Then the question comes, why there is an increase in molar conductivity on dilution? Now what happens when you dilute the solution? Let us suppose I've added water. Now this K plus and Cl minus gets distributed in more volume. If they are distributed in more volume, the force of attraction between the ions will decrease. And if forces of attraction is less, then the mobility becomes more. More the mobility, more is the activity. So that is the reason, it is because of the increase in the mobility. What do you mean by mobility? Movement of the ions. More the movement of the ions, more is the value of molar conductivity. So I will explain the reason. Dilution, forces of attraction between the ions decreases. So mobility increases. Hence molar conductivity also activity increases. So that is the reason why there is, if the conductivity increases due to number of ions, it increases to a larger extent. But in this case, it is increases only due to the mobility. That is why it increases to a lesser extent. It is due to the mobility. So this is one thing. In case of strong electrolytes, lambda m increases slowly, which is given by a equation, Debye-Huckel-Onsager equation. where lambda m naught is an infinite dilution and it is an intercept value. It means that it is a maximum value of molar conductivity when we add excess of water to it. After that, if you further add water, there will be no change. A is the constant here. Its value depends on the charges on the cations and anions. And when you plot a graph, you will get a straight line with negative slope. Why it is increasing? That is due to the mobility. That is one complete topic. Write it down. Then I will explain for weak electrolytes. If you have a doubt in anything, tell me. In case of weak electrolyte, lambda m increases sharply. First, tell me, all of you are done with the writing part of the previous topic. Strong electrolyte is done. Tell me, is it done or shall I wait? Can you hear me? Others?
Yes, ma'am.
You people are here or sleeping?
I am here, ma'am.
You are done with the writing part? Or still writing? Can't hear you.
Yeah, ma'am. Done writing it.
Advika and Pavan, you also done with the writing?
Yeah. Yeah.
Yes.
Okay. Now weak electrolytes, just plot a graph like this for weak electrolytes. It increases sharply on dilution. Why is it so? Because weak electrolytes are those which are partially ionized in the solution. And when you dilute it, the degree of dissociation will increase and number of ions formed will be more. So here there is a strong increase because of the increase in the number of ions. So you can write first definition. Weak electrolytes are those which ionizes partially in solution, like acetic acid, ammonium hydroxide, all weak acids and bases. On dilution, degree of dissociation increases so more number of ions will be formed. Means lambda m increases. So here it is because of the increase in the degree of dissociation. Because number of ions formed are more, that is why in case of weak electrolytes, there is a sharp increase in the molar conductivity. Now, Pavan, you tell me one thing. Can we calculate lambda m naught value from the graph for weak electrolytes? Strong electrolytes is intercept, where it cuts y-axis. Can we calculate for weak electrolyte from graph?
No,
Why?
because it does not cut.
Yeah. We cannot calculate the lambda m naught of weak electrolyte from the graph because it becomes parallel to y-axis. So there is another way to calculate it, which is Colruy's law. That I will not start today. So just write on one line, lambda m naught for weak electrolytes. For weak electrolytes cannot be calculated from graph. The line becomes parallel to y-axis. So to calculate lambda m naught, we use calculate that. We use Colruy's law.
Ma'am, in both cases, molar conductivity increases, right?
Molar conductivity increases in all the cases. Strong electrolytes may it increases slowly, but in weak electrolytes it increases sharply. That is the difference.
Oh, okay.
In strong electrolyte, it is only due to mobility. That is why it increases slowly. Isme new number of ions will be formed. So that is why it increases sharply.
Okay.
Now there is one question. All of you just listen carefully and tell me the answer. And this question came many times in exam also. Lambda m naught, lambda m, molar conductivity of A increases 25 times on dilution. Increases 25 times on dilution, and molar conductivity of B increases 1.5 times on dilution. A molar conductivity increases 25 times, B molar conductivity increases 1.5 times on dilution. Which one is strong, which one is acetic acid and which one is HCl? I will start from you have to tell me the answer. Out of A and B, which is acetic acid and which is HCl?
Ma'am, A is acetic acid and B is HCl.
Okay, other sure answer? Hmm. तो acetic
I'm
and
not sure.
acetic acid or HCl में से which is weak acid?
What?
Out of acetic acid and HCl, which is weak and which is strong?
HCl is stronger, right?
HCl is stronger, acetic acid is weak. So this graph, in which case the lambda m is increases to a larger extent, strong or weak?
Stronger.
Stronger के केस
Wait,
में तो
sorry.
lambda m
No.
is increases slow. Weak के केस में it increases to a larger extent. Strong के केस में it
Yeah,
increases
it's
to a lesser
opposite.
extent. So what should be A here? Acetic acid or HCl?
HCl.
A
No,
may
it's a weaker
increases how many
acid.
times?
So it'll be CH, the acetic acid.
A is
And
acetic acid because here it is increases to a larger extent. B is
yeah, and
HCl
B,
because
HCl.
here it increases to a lesser extent. Pavan,
Yeah.
is it clear this question?
Yeah.
Okay, now for you, I will give you another one. Plotting this graph, this line is A, this line is B, this is C. Out of ABC, one is acetic acid, one is acetic acid, another is HCl, third is NaCl. Now tell me which one is acetic acid, which one is HCl, and which one is NaCl? ABC.
So is 1 second. So A would be CH3CO, right? Isn't it? Yeah, and then B would be HCl and C would be NaCl.
Why? Why B is this one and C?
Because NaCl is very strong electrolyte.
HCl is also strong electrolyte. B and C both are strong electrolytes. Why
But
B
isn't
has?
NaCl the strongest?
नहीं, ऐसा नहीं है. Both are strong. HCl is C, NaCl is B. Why so? Both are strong. So both are completely dissociate. Out of H plus and Na plus, which has high mobility, which can move faster. Smaller the size, more is the mobility.
Okay.
Which can move faster, H plus or Na plus?
H plus.
H plus. So that is why higher molar conductivity is for H plus and lower is for NaCl.
Okay.
So these type of question they can ask. They can give you A ka itne times increase, B is increase this time, this much times. So which one is strong, which one is weak, or they can give you graph A, B, C. You have to write which is acetic acid, which is HCl and NaCl. This completes one topic. In next class, we'll finish this topic. Plus, we will start electrolytic cell. Mostly in 2 classes we can finish. Next week we will finish this chapter. So today, Advika, you are not writing. Pawan, I am sending you the test paper. What time will you write?
Ma'am, today I have a class from now till 9. Now is not right now, but from 7 to 9 I have class.
Then you write after 9. It's just a 45 minutes test paper.
Yeah, I'll see, ma'am. Ma'am, I'll text you.
Not text you. You have to write today itself.
Today only.
Ha. Because otherwise the full schedule will be upset.
Okay.
So I will share it. You just tell me at what time you will start writing.
Okay.
Okay. And Advika, for you it's on Monday, right?
Yeah. Yeah.
Others left. Okay. Any doubt here in today's topic?
No, ma'am.
No? Okay. Then we will wind up. Just revise thoroughly this topic. Because next topic is related to that. Okay. Thank you.
Thank you, ma'am.